Hi guys, Environmentally Great. Today we're going to touch very important topic in mathematics, further mathematics. That's we're going to talk about introductory calculus. Introductory calculus. A calculus is defined as the science of a very small quantities. It's the science of a very small quantities known as infinitesimal. Calculus is the science of very small quantities known as infinitesimal. Calculus is the science of very small quantities known as infinitesimal. It has two branches. There are two branches of calculus. We talk about the differentiation, that's the differential calculus, and the integration, that's also known as the integral calculus. The calculus, of course, is a singular word, which the plural is calculi. And when we talk about differentiation, we talk about integration, we are very much interested, we are pretty much interested in function, because when you are to differentiate or that you are to integrate, it is function that will be given to you and ask you to differentiate or to either differentiate or integrate. So we can't deal with differentiation or integration without talking about function. So we need to know functions, types of functions we have, look into varieties of function then, so that we at least know what we are differentiating or integrating. Okay, we have function. Of course, a function by definition, a function is defined as a process. A function is defined as a process by which a numerical input is transformed into a numerical output. A function is a process by which a numerical input is transformed into a numerical output. Function as a relationship or as a process a numerical inputs are transformed into a numerical output. That's each unique input must be processed the same way. So you have strings of inputs, that's the values of x and the values of x as the inputs, the values of y as the output. So before I still explain more on function, I will give you an alternative definition. We also say that a function could also be defined as the relationship between two variables. It's the relationship between two variables, the likes of x and y. We call, like we have, or a function is the relationship between two variables given that y is equal to f of x. So y is a function of x. So we have two functions defined in this setup. So we call y the dependent variable or the output variable, or times the codomain, while the dependent variable, the output, or the codomain. Then call x is the independent variable, the input variable, domain. So each value of x that defines a given function is known as the domain, and each unique output is known as the codomain. Okay, so we define function in two different dimensions. We talk about a function as a process by which a numerical input is transformed into a numerical output. A numerical input is a number and a numerical output is another number. One can say that's when we talk about the value of a function at a particular input. I can say given that y is a function of x and it is equal to 3x squared minus 4x. We see this function as the relationship between variable y and variable x, and we can decide to check this is the process by which an input is transformed into an output. When we say at x equal to 2, when x is equal to 2 is a numerical input, and this numerical input will be processed by the function. This is the function itself, which is a function of x. That's a function in x domain. We can have y is equal to f of 2, because when x is now 2, we have 3 into 2 squared minus 4 times 2. That's 2 squared is 4, and 4 times 3 is 12 minus 8. 4 times 2 is 8, and 4 times 3 is 12. 12 minus 8 is equal to 4. So the numerical input is 2 and the numerical output is 4. So this is the process by which this input is transformed into output. So this is the function we are talking about, which is actually a function of x. There are many other functions in different variables depending on the domain. Like there are functions, this is a function in x domain, we have function in p domain, function in t domain. Like a distance function is a function in time domain. For instance, one can say distance x is equal to 3t squared minus 2t plus 5. This is a function in t domain. In this case, one can say s is a function of t, because we have x outside and we have t inside, just like similar case here. We have y and this is the function in x domain. We say y is f of x. I can say also a function of p equal to p squared minus 3p plus 2. So this is a function in p domain. So be mindful when you want to define a function, ensure that the variable in question corresponds with the function you are defining. So I define a function of p and I have a function in p domain. So one cannot, there is nothing like f of x equal to t squared minus 3t. Something like this is out of it. So you must maintain the same variable which you depict. Alright, so this is function as a process by which a numerical input is transformed into a numerical output, and also function as the relationship between two variables, between a dependent variable and an independent variable. So now we're going to talk about different types of functions we have. We talk about different types of functions. We have types of function. I just have to mention not all, just a few types of function. So we have time for. We have even function. An even function. A function f of x is said to be even if f of minus x is equal to f of x. So this is the strict condition for a function to be an even function. Then note that a function that has an even power is an even function, and a function that has an odd power is an odd function. So we're still going to talk about odd function though. So what we have here is to establish that f of minus x is equal to f of x. How do we go about that? That is, where if we have f of x to be equal to x squared, let's check whether this function is even or odd. We are going to check f of minus x. F of minus x is equal to minus x all squared, and definitely when you substitute minus x, that's x is now having negative, and the negative square is always positive. That's the square of any negative number is a positive number. So this will equally give you minus x into minus x, which is still plus x squared. So we're having the same function, which is our f of x. Thus, f of minus x is equal to f of x. The condition is met, therefore the function x squared is an even function. But in a nutshell, to know an even function, the similar thing you look for is the common thing you look for there is the power. When the power is square, that's the square of any function is an even function. That's when the power is even number, then the function is an even function. When the power is an odd number, the function is an odd function. Just take down this method of knowing an even function. Let's talk about odd function quickly. Odd function. A function is said to be odd if f of minus x is equal to minus f of x. That is, if we have given that f of x is equal to s cubed, where x is equal to s cubed, we have f of minus x is equal to minus x all cubed. Definitely will give us minus x cubed. Since s cubed is f of x, therefore this means minus f of x. Therefore, thus f of minus x is equal to minus f of x. Therefore, f of x equal to s cubed is an odd function. So that's how to know an even function as well as an odd function. So when a function has an odd power, it is an odd function. When a function has an even power, it is an even function. Then a function that has both odd and even power cannot be taken as odd and it cannot be taken as even. So it is neither odd nor even. Okay, we have other functions, we have, and then to also interest me to tell you that sine of any angle, sine of any function is an odd function. Then cosine is an even function. Sine is an odd function, cosine is an even function. You can equally prove it using this particular method, because sine of any negative number is a positive result. Sine of any negative number is a negative result, while cosine of any negative number, you can be verifying this, you can pick up your calculator and punch sine of minus 30 definitely will give you minus 0.5, but cosine of minus 30 will automatically give you positive 0.8660. Okay, that's it. We have trigonometric function. Trigonometric function. So there is nothing much we need to know about this. It has to do with cosine function, sine function, and tangent function, and their respective inverse. The inverse of cosine is the sec, that's sec x. The inverse of cos x is sec x. The inverse of sine x is cosec x. The inverse of tan x is cot x, that's cotangent. Cotangent, that's sec x is the secant, cosecant, and cotangent. That's the inverse of cos, sine, and tan. So we have the exponential function, exponential function. Exponential function are the lines of, let's have y equal to exponential 3x squared plus 4. That's an exponential function, or you can write it this way. Y is equal to exponential 3x squared plus 4. And many other functions that contains this e, that has this e, is taken to be an exponential function. Just like when you see them, you recognize them. Then when we're going to get into differentiation, we're going to differentiate different functions in combination. Still on that type of function, we still have logarithm function. We have logarithm function, a function that has logarithm sign. Then we still have implicit function, a function that contains both x and y, that's coming together after the equal to sign. You see x and y that is linked together. For instance, we talk about implicit. We talk about a function of both x and y, a function containing both x and y, a function containing both x and y together. Like for instance, I can say x squared y cubed plus 3xy equal to 0. This is an implicit function. When we get to implicit definition and implicit differentiation, we are going to elaborate on that very well. Then the next thing we're going to talk about in the next section of this class is domain of a function. Thank you and stay tuned.